In this video, I'm going to take you through the basic trig identities as well as some of their rules. I'm going to use this video as a build up to my next video on where I want to concentrate and show you how we can prove different trig identities. I believe that video will be very important because a lot of the times in your exams, in your tests, you will get trig identities to prove. So stay tuned. Let us go through some basic rules around the whole trig identities, how we can derive some of the simple ones, and look out and be prepared for the next video because I want you to have your full concentration in the next video when I do upload it, and use this as your base or your foundation for that video. So let's jump in and get into our basic trig identities and rules video. The first rule that I want you to look at is the odd and even trig functions. And this is very important, especially when you are given some questions around it. So what I'm going to show you is in terms of odd and in terms of even, what this will actually look like for our different trig functions. So if you have sine of negative x, that is basically equal to minus sine of x. Now your x in here that I'm referring to is your angle, right? So just take note of that. Okay, on the other hand, cos of negative x, what do you think cos of negative x would be? It will end up being even as well. So cos of negative x, which is an angle, it'll remain as cos of x. Okay, let's take another one. Okay, what if we have tan of negative x? What do you think tan of negative x would be? Okay, so remember that tan is made up of sine divided by cos, and we already know that sine of a negative angle is negative sine and cos of a negative angle is positive. Negative divided by positive is negative. So tan of negative x would be equal to minus tan of x. Okay, happiness. So on the other hand, we can look at sec. Okay, so sec of negative x is sec of x. What about cosec, right? Cosec is the inverse, so we're going to say cosec of negative x is equal to minus cosec x. Okay, and then the last one I want you to remember is cot. So cot of negative x is equal to minus cot of x. Okay, so easy way to remember this is just remember that cos of negative x is cos of x, sec of negative x, let's excuse that, we didn't put the negative in there, so cosec of negative x is sec of x. If you remember these, then you know everything else that has a negative angle in it will always be negative. So just remember the two positive or the two ones that give you an even angle out. Okay, so that is the first set of rules that I need you to remember. I'm then going to move on to the basic trig function, and I think everyone knows this one. And this is, so your basic one here is, we know that sine squared of x plus cos squared of x is equal to 1. Okay, so this is the basic one to remember. You can actually derive and get all the other functions from here, and I'm going to show you that now. So what happens if we divide this entire basic function by cos squared of x? So let's do that, right? Or sine squared of x. Let's do sine squared of x. So let's say if we say we're dividing this by sine squared of x, we're dividing that by sine squared of x, and we divide that by sine squared of x. Okay, now sine squared x divided by sine squared x is 1. Bring down the plus sign. Cos squared of x divided by sine squared of x is what exactly? That is the inverse of tan. Okay, and the inverse of tan is cot. Don't remember the square, so square of x is equal to 1 divided by sine squared x, and 1 divided by sine squared of x would be cosec. This is the inverse, cosec squared x. Okay, so we were able to take the basic function and derive this function from it. Okay, or this identity from it. Simple one. Let's do the same thing, but let's this time do it for let's do it for cos squared of x. Okay, so if we're gonna do this for cos squared of x, let's just write this again. We know that sine squared of x plus cos squared x is equal to 1. Now let's divide both sides by cos squared x, cos squared x, and cos squared x. Okay, this is sine over cos, which is tan. Square of x plus these will cancel, so that's 1, and this is the inverse of cos, so we're going to call it sec squared x. Okay, so quite simple how we can take the basic trig function of sine square of x plus cos square of x equals to 1, and derive the other functions or other trig functions from it. So if you have the time, go ahead and use this and see how you can derive all the other functions from it. It is the basic or the foundation that we need to know, and like I said in this video, I am going to show you the basic and the foundations and the different rules, because I want to go ahead in the next video and show you how we can prove trig identities, which is my main aim, as you will get trig identities to prove in any exam, in any test, and I do want you to score the highest in those. So let's look at some of the angles again, and this time I want to look at these types of angles and show you what they can equal to, and yeah, something again that you can remember or maybe by heart if you want to, because these won't change. So let's say we have cos theta. Okay, cos theta is the same thing as sine 90 degrees minus theta. Okay, so what is sine of theta? So sine of theta is equal to cos of 90 degrees minus theta. Same thing cosec. So if we have cosec of theta is equal to sec of 90 degrees minus theta, and cot of theta is equal to tan of 90 degrees minus theta. So once again, something to remember and to understand. I'm going to show you one of them right now, how we understand those. So between the relationship between cos and sine. So if you have, what if we had cos of 0 degrees? Okay, that's basically, according to that, we're saying it's not sine of 90 degrees, right? It's sine of 90 minus theta. Theta is 0 degrees, so it's 90 degrees. What happened if I said we have cos of 10 degrees? That's equal to sine of 80 degrees. What if I said we have cos of 30 degrees? that's equal to sine of 60 degrees. So can anyone see the pattern here that I'm showing you? So the pattern that's occurring here is, if you look at it closely, right, and you ever come across this, is we said cos of 10 degrees is equal to sine of 80 degrees, cos of 30 degrees is equal to the sine of 60 degrees. Okay, look carefully at what theta is in here. Okay, so we're saying that cos and sine must equal to what specific theta angle? So if you look at this, 80 plus 10 is 90 degrees. 60 and 30 is 90 degrees. 90 and 0 is 90 degrees. Okay, so that's the pattern we are showing here, and that's the basic rule. So if we have cos and sine, we know that both of them must equal to 90 degrees. The sum of both of them must equal to 90 degrees. Okay, so pay very close attention to these, especially when you do get them in an exam or with the triangle itself and you've been asked these type of questions, and maybe you only given the cos side of things and you need to go find it in terms of sine. So just remember that if you have cos of any angle and sine of any angle, the summation of both of them must be equal to 90 degrees. Okay, that was quite a simple, interesting one to remember. The next one I want to look at is, what if we have double angles? So what do we do with double angles? Okay, so on the double angle side of things, what if we said we have sine 2 theta? Okay, that is basically equal to 2 sine of theta cos of theta. Okay, sine 2 theta, 2 sine of theta, cos of theta. Another simple one to remember. What if we have cos of 2 theta? So what's the difference here? So cos of 2 theta is equal to cos squared theta minus sine squared theta. Okay, and that can actually equal to 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. Okay, so cos squared theta can be equal to all of those. So another one that you can just pay attention to and try to remember, and ones that you can also derive, right? So like I said, this video, I just want you to remember the basics. So I'm going to just show you all the different rules as well as formulas for identifying the trig identities. Now I'm going to take you through the next one, and I need you to pay very close attention to this, as this is going to be your sum and difference trig identities, right? So here, let's start with sine. So if we have sine of a plus or minus b, that is equal to sine, let me actually write this at the bottom, that's equal to sine of a cos of b plus and minus cos of a sine of b. Now take very close, or pay very close attention to the signs, right? Very important to look at the signs. We can see here that if we have a plus here, in both pluses must be the same. If we have a minus, then we have a minus. Okay, so just pay very close attention to that. And the reason I'm bringing that to your attention and calling that out is for you to see this. What about cos? So if we have cos of a plus or minus b, that is equal to cos, let me just write at the bottom again for space, so that's cos of A cos of B minus plus sine of A sine of B. Now, this is the reason I was bringing the signs to your attention. For cos, we inverse. So if you have a plus up here, we're going to use a minus here. If you have a minus, we're going to use a plus there. Okay? So pay very close attention to your signs with cos. Okay? They're not as straightforward as the sines. Let's do one more, right? Let's do tan. So pay very close attention to tan, and I like this one. So if we have tan of A plus or minus B, what do you think this is equal to? So this is equal to tan of A plus or minus tan of B. Straightforward there. However, it's all divided by 1 minus plus tan of A tan of B. Once again, pay very close attention to the signs. We can see when it's a plus here, it's a plus there, but it's a minus down here. Okay? When it's a minus there, it's a minus here, but it's a plus down there. Okay? Please check your signs. For sine, it's very simple, straightforward. For cos, it's different. For tan, it's different. Okay, so just pay very close attention when looking at or having these types of questions or examples, especially when the angles are involved. It does get a bit more complicated and a bit more tricky, but just to remember these, right? So the next thing I'm going to show you is the power reducing formulas. Sounds complicated, but not really that complicated. So power reducing. Okay, so for power reducing, I'm going to take the simple examples, or the common ones that you would usually get. So sine squared theta can be rewritten as 1 minus cos 2 theta all over 2. Okay, then cos squared theta, that's equal to 1 plus cos of 2 theta all over 2. Okay, once again, just remember the signs here, right? They're different. Okay, signs play a crucial role with your trig identities. Tan squared theta, that's basically equal to 1 minus cos of 2 theta all over 1 plus cos of theta. Okay, that's quite simple. Power reducing formulas, how you can take your sine squared, your cos squared, and your tan squared and rewrite them into easier formulae or formulas to remember. Okay, so pay attention to these. Quite simple, but very helpful in the whole trig world, right? Especially in your exams and your tests. What should we look at next, right? So let's look at the product to sum. Let's look at that, right? So if we have product to sum, let's say we have sine of A, sine of B. Now that is equal to a half into cos of A minus B minus cos of A plus B. Once again, pay very close attention to the signs, right? Sign there, sign here, and the sign there. Okay, Let's take another one. Let's take cos. Let's take, say we have cos of A, cos of B. What do you think this is? So this is a half into cos of A minus B plus cos of A plus B. Okay, once again, signs come into play here. You can see how it is different between sine and cos. Let's take another interesting one. Let's say we have sine of A cos of B. Say that's equal to a half. Let me actually write this at the bottom. So that's equal to a half into sine of A plus B plus sine of A minus B. Okay, very important, okay, to understand this. And look at the next one, right? What if we had cos of A sine of B? Okay, once again, you guessed it, it's gonna be a half into sine of A plus B minus, right? Once again, pay attention to the sign. Minus sine of A minus B. Okay, very important. Product to sum. It will assist you and help you in your exams and your tests, especially to simplify your trig identities or your trig functions that you get. Or you might even get a question where you're given cos of A sine of B. You're given what A is, you're given what B is, and you've asked to put it in this form and simplify it further. Okay, let me take you to the last one. So this is another good one to remember, and this ones are going to be our sum to product. Okay, now for sum to product, let's take a look at this. So what if I had sine of A plus sine of B, and I need to put it into a product, depict it as a product, or be able to simplify this further. So we can use sum to product here, and by doing that we would have this rewritten as 2 sine of A plus B over 2 cos of A minus B over 2. Okay, simple. What if I had sine of A minus sine of B? What do you think this is now, right? So that will be equal to 2 sine into A minus B over 2 cos of A plus B over 2. Okay, so see the difference between the two, right? The signs are very important here. Okay, let's look at another one. Let's change the color, use something bright. What if we went with cos? So if we had cos of A plus cos of B, what do you think this is? This is equal to 2 cos of A plus B over 2 cos of A minus B over 2. Okay, so just ensure here between the sine and the cos one, you can see very similar, but we're using cosine here, right? So just pay attention to those as well. The way the sine and the cos are different, and in some ways slightly similar. So what if we had cos of A minus cos of B? What do you think this is? this is equal to minus 2 sine of a plus b over 2 into sine of a minus b, all divided by 2. Okay, and that brings us to the end of this video of the basics in terms of your trig identities as well as the rules. Please go through them, write them down to remember them, because you will get some of these in your exams, in your tests, and by remembering the rules, you'll be able to go ahead and simplify a lot of your trig identities, your trig functions, and be able to get full marks. Also watch this video very carefully, because I am going to upload my next video directly after this, where I am going to show you how to prove some identities, and we're going to use some of these rules in that video. So stay tuned, look out for that video. Ensure you hit the like and subscribe button, and all the best for your exams, your tests, and for your trig sections in your mathematics. Take care, and I will see you around.